Okay, 5.3C, College Algebra, page number 465. We're going to look at the row echelon form, the middle of 465. And what we did is the last matrix in example 1, that was a 1, -2, -10, -6, 0, 1, 8, 3, 0, 0, 1, -1 half. Okay, that is in what's called row echelon form, and if you look here at the rules there for a row echelon form, let's look at it. If a row does not consist entirely of zeros, then the first non-zero element is a 1. So this does not have all zeros, none of these do, but the first non-zero element is a 1. For any two successive non-zero rows, so these two are non-zero rows, in fact all three of them are, but these two are non-zero rows, the leading one in the lower row is further to the right than the leading one in the higher row. So this one is further to the right than this one. This one is further to the right than this one. Okay? 3. All the rows consisting entirely of zeros are at the bottom of the matrix. Okay. We don't have any that are all zeros, but if we did, they would have to be the last row of the matrix. And the fourth property, if it's going to be a reduced row echelon form, each column, up and down, that contains a leading 1 has zeros everywhere else. So this has a leading 1, zeros. Leading 1, below it has zeros. Leading 1, well, you know, obviously there's no zeros there. But if it is in reduced echelon form, then all of this will be zeros. So we have a leading 1 here, 0. Leading 1 here, zeros. 1 here, zeros. Okay, and that's not the case here, so it's not reduced, but it is in row echelon form. Okay, so let's look at example 2, and they're just giving you A, B, C, D, E, and F, and they're asking which ones are in row echelon form and which ones, if any, are in reduced row echelon form. So if you look at A, D, and E, those are all three, A, D, and E. They're all three in row echelon form. B and C, the first non-zero elements, are not ones. They're like in B, the first one is a -1, so that doesn't work. And C, the first non-zero in row 2 is a 3, so that doesn't work. Okay, let's keep looking. D and E. Not only are the row echelon criteria met, but each column that contains a leading 1 also has zeros everywhere else, so these matrices are reduced row echelon form. Now notice, on the other side of the vertical line are numbers. That's okay. It's just the left-hand side of the vertical line there that we're really concerned about. We're interested in the coefficient matrix, the numbers that are on the left of the equal sign. Are they all zeros and ones? If so, then we're good to go as far as it being in reduced row echelon form. Okay, so that's it for that. That brings us up to page 466, Gauss-Jordan elimination. So let's look at a different way of doing this. The difference between Gauss-Jordan elimination and the other procedure we did, which was the Gaussian elimination, is the Gauss-Jordan elimination. What we will do is we will keep applying those operations that we did in the last one, moving things around, multiplying, dividing, and getting everything to be ones and zeros until everything in the entire coefficient matrix is going to be ones and zeros. So we're going to do a couple of those, but I don't really push the Gauss-Jordan elimination a whole lot. I'd rather have you be really familiar with the Gaussian elimination that we just did. but I want you to be familiar with this other way, so we're going to go ahead and do 1. So I'm going to call that 5.3D.